Hi everyone, this is a video on solving equations by factoring. Before we start solving equations, let's just talk about the standard form, and we'll do it for a quadratic equation. So the standard form of a quadratic equation, we'll talk about what that means in a second, is ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and we say a doesn't equal 0. So the standard form basically says you want everything on one side of your equation and 0 on the other side. A quadratic equation means that the highest power is 2, right? Or the degree is 2, right? So the highest power is 2. That's what this really means, quadratic. Standard form means everything on one side, 0 on the other. A, b, and c are real number coefficients. The x squared and the x are going to stay variables, right? So there's going to be variables in there. We say a doesn't equal 0 because if a equaled 0, then we'd have 0 times x squared here, and then that would make this not a quadratic, right? Because then this would be just 0, this term, and you'd have a linear term, meaning something with the first power. So basically when you're solving equations by factoring, you really want to get one side of the equation equal to 0, and then we're going to solve from there. The way we're going to solve this is by using what we call the zero factor property. So the zero factor property is probably something that you have an understanding of, but probably haven't seen written formally. But the zero factor property says for any two real numbers a and b, if a times b equals 0. So if I multiply two real numbers together and I get 0, that really tells me something. What can you say about the numbers? Well, if two numbers multiply together to give me 0, the only way that can happen is then either a equals 0, b equals 0, or both a and b equals 0. In other words, if I multiply two things together and I get 0 out, at least one of them has to be 0, if not both of them. But this is going to be really important because the way we're going to handle this is that, when you have something that's quadratic in form and you get it in the standard form, you're able to factor the left side. Remember, you get a product. And if I have things that are being multiplied together to give me 0, once I factor this, then I know that either the first part's 0 or the second part is 0, or both could be 0. So we're going to use this in an example. And this one will give us the idea of what's going to happen going forward. So in this example, I'll say to solve x plus 6 in parentheses times x minus 1 equals 0. Now when you look at this, first off, don't FOIL through and distribute through. What we're really doing is we're looking at this as something that started out in quadratic form, and you know that if you factor it, you would end up here, right? So this is already in factored form. But the key to this is what I really want to show you is that we have something where we can use a zero factor property. We have 0 on one side, and we have two things that are being multiplied together to give me 0. So if I have two things multiplied together to give me 0, what it really says, based on the zero factor property, is either the first thing 0 or the second thing 0, right? Or both. So if I say I have this x plus 6 times this x minus 1 and equals 0, then I know that either x plus 6 equals 0 or second thing, x minus 1 equals 0, right? So one of these factors needs to be 0 at least for this to multiply to give me 0. And then once you do this, you have two linear equations. Say linear equations, I mean things with the first power. You can solve these like you normally would, meaning get the variable alone on one side. So for this first one, I'll subtract 6 from each side to isolate x, and end up with x equals negative 6. Or here, x minus 1 equals 0, so I'm going to add 1 to each side to isolate x, and I get x equals 1. So we have two answers here. And we can write this in set notation if you want. Curly braces represent a set. We have negative 6 and 1. Now, I don't care if you write it like this or if you write it in the set notation, but you should be able to understand both if you see them. If I ask you to check this, we won't check all of these, but just to give you an idea of how this checks out. You check one of these solutions at a time. What it's really telling me is negative 6 would make this equal 0, and 1 would make this equal 0 when I sub it in for all of the x's. So if I say to check x equals negative 6, what I'm really doing is I'm subbing negative 6 into here, right? So I'd have negative 6 plus 6 times negative 6 minus 1. We want to know, does that equal 0? Well, when I do that, negative 6 plus 6, well, it's 0 times negative 6 minus 1 is negative 7. Does that equal 0? Yeah, 0 times negative 7 is 0 equals 0. So it checks out. So negative 6 works. And then you want to check x equals 1. So we would have, now again, you're subbing in 1 for all the x's. Don't sub the negative 6 and the 1 at the same time. So we're subbing in 1 for x. We'd have 1 plus 6 times 1 minus 1. We want to know, does that equal 0? Well, looking at this, 1 plus 6 is 7 times 1 minus 1 is 0. Does that equal 0? Yeah, 7 times 0 is 0 equals 0. So it checks out. So you know those are solutions. Keeping in mind that, you know, both of these do check out, but you have to check them individually. I wouldn't say you have to check every answer, but if you want to be sure you're right, you know, it's helpful to check. So that one was already given to you in a factored form. Let me write out the steps here to solve when you're factoring. All right, so solve by factoring. Solve by factoring. First thing you want to do is you want to use addition slash subtraction. Right, so addition or subtraction to get the equation in standard form. When I say standard form, we talked about it earlier, right? The ax squared plus bx plus c equals 0. In other words, this is really the way to think about it. Get one side equal to 0. When I say sides, I'm talking about the equal sign is separating the sides of these, right? So these are equations, so we're solving for the equation. You factor expressions, you solve equations. So I want to get one side equal to 0 at the beginning if it's not already set up that way. Step 2, you want to factor the, what I'll call non-zero side, right? The ax squared plus bx plus c side completely. Once you've done that, right, you factor everything completely, you'll have a bunch of factors being multiplied together. You have a product. And when you have things multiplied together equal to 0, what you can do is you can set each of those factors equal to 0 using the zero factor property. So we'll say set each factor, and this is kind of important, containing a variable. Right, so each factor containing a variable equal to 0. In other words, we're using the zero factor property, setting all the things that are being multiplied together equal to 0. But remember, it has to be a factor containing a variable, because if it's a constant, you know, let's say it was 5, you don't set 5 equal to 0, because 5 could never be 0. Once you've created these equations, we're doing something similar to what we did up here. Right? We set each factor equal to 0, and then we solve. Right? So you want to solve each equation. From what I'll call step 3. And then step 5, we're not going to do this for every problem, but you should understand that you should check to make sure your answer works. So the process is get one side equal to 0, factor completely on the non-zero side, set each factor that contains a variable equal to 0, and then solve for each of those equations you created. That'll give you the solutions to the equation. The solutions are, remember, what makes the equation true or makes it, you know, hold. So let's take a look at an example. If I said to solve, and the directions here will be solve. Remember, you solve equations, so you know you're solving when you see an equal sign in there. You factor the expressions. So if you factor, if the directions are factor, you don't set it equal to 0 because it's not an equation. So if we said to solve, 7x squared equals 56x. All right, the first thing you should do, remember, is you want to get one side equal to 0. You know this because you have, you know, a quadratic. You have power of 2. And really, for any power of 2 or higher, you're going to want to solve this way by getting one side equal to 0. So to get one side equal to 0, I'll move the 56x out of the right side over to the left, and I do that by subtraction because this was a positive 56. So we're going to subtract 56x from each side. Now remember, these aren't like terms. You can't combine them. So you are actually going to write them just in a line. So we have 7x squared minus 56x equals 0. Make sure you write it in descending order. That's important when you're factoring. Once we've got one side equal to 0 like we do now, we want to factor this non-zero side. So this left side of the equation here, 7x squared minus 56x. Remember, when you're factoring, the first thing you look for is always a GCF. For 7 and 56, they share a 7 in common. X squared and x, they have an x in common. So 7x is a GCF. I'll factor that to the front. And then remember, when you factor something out, you divide out that factor to figure out what's left on the inside. So 7x squared factoring out 7x gives me x. Negative 56x divided by 7x, or factoring out 7x, gives me negative 8. Close the parentheses. Make sure you still have this equals 0. Now once I'm here, remember the next step said, well, it says set each factor containing a variable equal to 0. So we can set each of these equal to 0. I'll set 7x equal to 0, and I'm going to set x minus 8 equal to 0. And when I do this, 7x equals 0, I'll divide by 7 on both sides. Solving that first equation, we get x equals, remember, 0 divided by anything is just 0. You need that. Don't just drop it. You need to have x equals 0. It's one of your solutions. For x minus 8 equals 0, remember you solve this by adding 8 to each side. You get x equals 8. So we have two answers here, right? So my solution set would be 0, comma 8 in set notation. If you left it just as x equals 0 and x equals 8, I'd give you credit for that. But these are the values for x that would make the original problem true, right? That's what we're trying to find when we solve. I'm not going to check this one, but you could check them for yourselves if you wanted to. Let's take a look at another example. If I said to solve x squared plus 13x plus 42 equals 6. All right, so first thing we want to do, you have to get one side equal to 0 because I see, you know, I have an x squared in there. So to get one side equal to 0 in this equation, I want to move the 6 over to the other side. So I'm going to subtract 6. When I subtract 6 from this side, you have to also do it to the other side. When you subtract 6 from this side, make sure you do it from its like term. So I'm going to take it from 42. So I'm left with here x squared plus 13x plus 42 minus 6 gives me a positive 36. This all equals 0. Make sure you have this equals 0. Don't forget it. Remember, that's what makes it an equation. You can't solve it if it's not an equation. So you need equals 0 on there. And then once you've done that, on the left side, now we want to factor completely. Remember, follow your steps for factoring. All right, so first thing you want to look at is, is there a GCF for the whole thing? In this case, nothing other than 1. All right, how many terms do you see? Well, I see 3 terms. Do I see a value in front of my x squared other than 1? No. So that tells me right away I can factor this down to 2 sets of parentheses. The whole thing still equals 0. Factoring this down, x squared means I can have x times x. On things that multiply, remember, to 36, they have to also add to 13. So what multiplies to 36 and adds to 13? All right, so we have to find those numbers. Well, those numbers are a positive 9 and the positive 4, right? Because 9 times 4 gives me 36. 9 plus 4 gives me 13. This doesn't factor any further. You can look inside of here. These are just both linear factors. They don't factor any further. So looking at this, I take each of my factors, right? Things that are being multiplied together equal to 0, and I set each of them individually equal to 0. That's what the 0 factor property tells me. So I can set x plus 9 equals 0. Or I've got x plus 4 equals 0, right? So each factor equal to 0. And when you do that, now you're ready to solve each of these individual equations. So here to solve for x, I subtract 9 from each side. I get x equals negative 9. Here, I'll subtract 4 from each side. I get x equals negative 4. And so I have 2 answers. The 2 answers, my solutions, are negative 9 and negative 4. This is just writing that same answer in set notation inside curly braces. Keeping in mind, negative 9 and negative 4 are what make this original problem true. One thing to mention here is you don't want to try to factor this right away. Remember, the first step is get one side equal to 0. So don't try to factor it just because it looks like it factors, right? You have to get one side to 0 first. Let's say we were to solve this next one. If I said to solve x plus 5 times x minus 2 equals negative 6. So the first thing I would note is that, on the left side I have these 2 factors that are being multiplied. On the right side I have negative 6 though. So, your first instinct might be to try to set each of these equal to negative 6, but you can't do that. Remember, we only can set factors equal to 0 because the 0 factor property tells us that if 2 things are multiplied together and it's equal to 0, then one of them has to be 0. But here, because 2 things multiplied together give you negative 6, doesn't mean one of them has to be negative 6. You could have numbers that don't fall into that case. So you really do have to get one side equal to 0 first. And before I, try to get 0 on this right side and move the negative 6 out of there, I'm going to actually FOIL, right? I'm going to distribute through on the left side. So then when I move the negative 6 over, I'll have a like term to combine it with. So I'm going to FOIL first. X times x will give us x squared. X times negative 2 will give us a minus 2x. Positive 5 times x is plus 5x, and positive 5 times negative 2 is negative 10. This is equal to negative 6. We'll combine like terms, so I have x squared, negative 2x plus 5x is a positive 3x minus 10 equals negative 6. And now once I'm here, now I'll get the one side equal to 0. So to get the right side equal to 0, to make this negative 6 a 0, I add 6. Remember, add 6 to the other side as well to keep it balanced. You do it to its like term. So I have x squared plus 3x minus 10 plus 6 is negative 4. And then that whole thing equals 0. Make sure you still have an equation here, right? You're trying to solve the equation. Another thing to point out is if it didn't have a like term to combine with, just make sure you put it in the appropriate place in the descending order when you move that term over to the other side. So once I'm here, I got 0 on one side. I want to try to factor the non-zero side. Factoring the non-zero side, first look for a greatest common factor, right? GCF is our first step always when we're factoring. In this case, I don't see a GCF other than 1. You ask yourself how many terms you see. I have 3 terms here. Do I see a value in front of my x squared? The answer is no, right? It's just a 1. So if I don't see anything other than 1 in front of x squared, two sets of parentheses right away, this whole thing still equals 0. X squared is x times x. Want things that multiply to negative 4, right? They have to multiply to the constant and add to the middle coefficient, which is a positive 3. Multiplying to a negative 4 tells you the signs need to be opposite to multiply to a negative. To add to 3, you know, the larger one in absolute value should be the positive, so I got, I think, positive 4 and negative 1, right? 4 times negative 1 is negative 4. 4 minus 1 gives you the positive 3. Once you are here, right, we have this factored completely. You have things that are being multiplied together give you 0, so that's the zero factor property. You can say x plus 4 equals 0, setting the first factor equal to 0, or x minus 1 equals 0, setting the second factor equal to 0. Solving the first one, we subtract 4 from each side, we get x equals negative 4. Here we'll add 1 to each side to isolate x, we get x equals positive 1. So my solution set is negative 4, 1. Now remember, this solution set, it's not an ordered pair, it's not a point on a graph. It's just, you know, the x values that are the ones that make the original problem true. Make that equality hold. Let's take a look at another one here. If I had to solve this. Alright, so 5x squared plus 9x minus 2 equals 6x. Alright, so I'm trying to solve this quadratic equation. So the first thing I want to do is get one side equal to 0. So I'll subtract 6x from the right side. To do this to the left side, make sure you take it from its like term. So I end up with 5x squared. Positive 9x minus 6x is a positive 3x. Watch your sign there. And then here we have minus 2. This whole thing equals 0. And then I want to try to factor the left side. So the first thing is you're looking for a greatest common factor for the left side. And in this case, there isn't a greatest common factor other than 1. So we can't factor anything out right away. All right, once I look at that, I count my terms. I have 3 terms. And then I say, okay, do I see a value other than 1 in front of x squared? And I do. I see a 5 there. So that tells me I want to either do a trial and error or attempt an AC method. So we'll do AC method with this, just kind of as a refresher how that works. Remember, AC method is a rewrite method of the middle term, so you can use factor by grouping. So for AC method, you want things that multiply to AC. Remember AC, this is A, B, C are the coefficients in that order. So AC is 5 times negative 2, which equals negative 10. They have to also add to whatever B is. In this case, B is positive 3. So multiplies to a negative 10 and adds to a positive 3. Well, it happens to be the values that we already had. It doesn't always work this way, right? But 5 times negative 2 gives me negative 10. 5 plus negative 2 does give me 3. So those numbers check out. So you're using 5 and negative 2 to rewrite that middle 3x. So when we go to rewrite this, remember the ends stay the same. So I'm going to start with 5x squared. That doesn't change. We're replacing with the positive 3x with the numbers I found. So positive 5, make sure you bring the x along. Minus 2, bring the x along. Because remember, we're really uncombining those like terms, right? So these have to both have the same variable. And then minus 2 stays minus 2. So you're just rewriting the middle strategically. The whole thing still equals 0. And then from here, we will use our factor by grouping, because now I have 4 terms. So when I have 4 terms, we use grouping. For the first group, you're looking for a GCF. So 5x squared and 5x share a greatest common factor of 5x. For negative 2x minus 2, remember the first term being negative tells you take out a negative. They share a factor of 2 in common. You can't take any x's because there's none on the last term. So simplifying this here, factoring out 5x from the first 2 terms, 5x squared divided by 5x just leaves me with x. Positive 5x factoring out 5x. Make sure you put something here. It's not just cancels and put 0. It's 5x divided by 5x. Whenever you divide something by itself and it all cancels out, there's really positive 1 there, right? When you divide something by itself, you always get 1. So positive 1. Here you're going to write the negative 2. Make sure you bring the sign with it. It's important. And when you figure out what's inside of these parentheses, when you factor it out, make sure you divide looking at the sign. So negative 2x divided by negative 2 makes us a positive x. Negative 2 divided by negative 2 makes us a positive. Make sure you put 1. Don't cancel those out. Equals 0. Factoring this side. Now what do these two terms have in common? Remember, that's how grouping works. Well, these have x plus 1 in common, so you'll factor x plus 1 out of there. Then what's left over from the front of each of these terms when you factor it out? Well, we have 5x minus 2. This all equals 0. And then you want to set each of your factors equal to 0. So remember, now it's factored completely. Now we're allowed to set each of the factors that have a variable equal to 0. So I set x plus 1 equal to 0. I set 5x minus 2 equal to 0. Solving the first one, I'll subtract 1 from each side to get x equals negative 1. That's one solution. For the other one, 5x minus 2 equals 0. Remember, you got to isolate the x term first. Sometimes people get thrown off by this, right? So don't forget what we used to do. When you have 5x minus 2 equals 0, you isolate the x term. So I'm going to add 2 to each side. If 5x equals 2, don't stop there. Remember, the goal is solve for x, so we want to divide by 5. Remember, 5x means 5 times x, so you divide by 5. You divide by 5, so you get x equals 2/5. So our solution set, all right, just making sure, see there's two answers. All right, we have negative 1 and 2/5, and those are in set notation inside curly braces. Those are the x values that make the original equation hold, right, or make the original equation true. Something to point out, you typically are going to get two answers for this. You know, we've gotten two answers for all of the ones we've had so far because the highest power you see is 2. Keep in mind, though, that occasionally, you know, you might have something that's not factorable. You might also have things that have a repeated solution. So you might get, you know, negative 1 show up twice here, but it really only has one answer because it's the same answer twice. All right, let's take a look at just a few more. If I said to solve (3x squared plus 7x minus 24 equals x. So again, first thing you want to do, get one side equal to 0. So I need to move this x term over to the other side. Let's subtract x. Subtract x. End up with 3x squared. Positive 7x minus x is positive 6x minus 24 equals 0. And then after that, you want to factor this left-hand side completely. Factoring the non-zero side completely, first thing you look for is a greatest common factor. In this case, 3x squared plus 6x minus 24. It does have one. There's a GCF here. The GCF is 3. Remember how it works. When you take out a greatest common factor, you factor it to the front, and then you want to factor it from each term. So 3x squared taking out the 3 gives you x squared, plus 6x taking out the 3 gives you plus 2x. Negative 24 factoring out 3 gives you negative 8. Close that parenthesis off equals 0. Remember, once you factored out a GCF, you want to look inside of here to see if you can factor any further. So you count the number of terms you have, which in this case we have 3. You look to see if you see a value other than 1 in front of your x squared. We don't, so we have a 1 in front of our x squared. So if this is going to factor, we can do it with 2 sets of parentheses. Remember, the GCF stays the GCF in front. 2 sets of parentheses because we have 3 terms and you don't see a value in front of your x squared. That tells us we can make this just x times x at the beginning. We want things that multiply to negative 8. They also have to add to a positive 2. We want to find numbers that do that. So numbers that multiply to a negative 8 and add to a positive 2. Well, those numbers are positive 4 times a negative 2, right? 4 times negative 2 gives you negative 8. 4 minus 2 gives you 2. This whole thing still equals 0. Don't lose that. So a couple things. GCF comes down in front, stays in front. And then when you factor this, you're counting the terms. And then you notice there's no value in front of your x squared other than 1. So that you can make two sets of parentheses right away. Once you're here, remember what we said. You want to set each factor containing a variable equal to 0. Now, 3 is a factor, but does 3 equal 0? Well, that doesn't really make sense, right? You don't even have to really deal with it. If there was a variable with it, you would, but 3 doesn't equal 0. You don't even have to use it. 3 is not part of your answer. Sometimes at the end of the problem, people try to throw 3 in there. 3 is just there because it's a GCF in front, but since it's a constant, 3 could never equal 0. Remember, the zero factor property is what's allowing us to make this equal 0. So if I have these three things multiplied together and it equals 0, either this has to be 0 or this has to be 0. But 3 can't be 0, and 3 is not a solution for x. So any factor that contains a variable set equals 0. So we have x plus 4 equals 0, and x minus 2 equals 0. And now we can solve each of these individually. Subtract 4 from each side. I get x equals negative 4. Here I'm going to add 2 to each side. I get x equals 2. So my solution set, we've got negative 4 and 2. And that's it. Do not include the 3 in there. Now, if you factored out a 3x, kind of like we did in the very first example, you factored out 3x, then you would be able to set that equal 0 because it had a variable with it, and you'd solve for it. We did that earlier. If you go way back up here just to see it, when we took out a 7x on this example here, we took a 7x out, and then we set that equal to 0 because they had a variable with it, so you could solve for x. Here, when we looked at this one down here that we just did, you can only factor out a 3 without a variable. If it's a constant, you can never set it equal to 0. If it has a variable, you have to set it equal to 0. Let's just take a look at a few more. If I said to solve 5x squared minus 20 equals 0. So we already got the standard form. We already have it equal to 0, which is nice because we don't have to worry about that step. And then you want to think about what are your steps when factoring. Well, the first thing I look for is a GCF. If I'm looking for a GCF here, the greatest common factor between 5x squared and 20, you have a GCF equals 5. So I'm going to take 5 out to the front, and I'm left with x squared minus 20 divided by 5, or 20 factoring out to 5 makes us minus 4. The whole thing equals 0. And then once you've done that, remember GCF in front will stay in front. And you want to look at the inside, count your terms. I have 2 terms. If I have 2 terms, I should think to myself, okay, is that the difference of perfect squares? Because if it is, then you can factor it. If it's not, then you won't worry about it. So is this a difference of perfect squares? Well, it's a difference. It's got subtraction. X to the second power, that's perfect square because it's an even power. 4 is a perfect square because it's a number times itself. So yes, it is. So the 5 comes down. For difference of perfect squares, remember you make 2 sets of parentheses. Whole thing still equals 0. X squared, you know, we want x times x. For this to be negative, we need a positive times a negative. And then 4 is what number times itself? Well, it's 2 times 2. So we have 5 times x plus 2 times x minus 2. You should check to see if these factor further. In this case, they don't. So now you want to set each of your factors, once it's factored completely, equal to 0. Remember, each of your factors containing a variable. So for 5, does 5 equal 0? No. So we don't use 5. It's out of the problem. You can say 5 doesn't equal 0 here. You don't even have to show this, but make sure you don't use it accidentally. For these other 2 factors, make sure you set them both equal to 0 because they have variables with them. So we have x plus 2 equals 0 and x minus 2 equals 0, and then we solve those individually. So I'll subtract 2 from each side here. We get x equals negative 2. Here I'll add 2 to each side. I get x equals positive 2. So my solution set, all right, is negative 2 and positive 2. All right, inside curly braces because that's indicating that it's a set. And let's take a look here at this one. If I said to solve negative x squared plus 5x plus 6 equals 0. Again, we already got the standard form. All right, we got 0 on one side. And when I look at this, the first thing you should look for is the greatest common factor. Now, if you're looking at these terms, you may not see one other than 1. But if the first term's negative when you're factoring, remember, this goes back to something we talked about much earlier. You always want to take out a negative if the leading coefficient's negative, and that's just going to make it easier to factor. If you don't, you could still work with it, but it makes it a lot more complicated, and usually people make errors. So I'm going to factor out a GCF of, I know I need a negative, and the only thing they have in common is 1, so I'm going to factor out a GCF of negative 1. And when I do that, basically all the signs change, right? Negative x squared factoring out a negative 1 means you're dividing by it, makes us a positive x squared. Positive 5x taking out a negative 1 makes us a negative 5x. Positive 6 factoring out a negative 1 makes us a negative 6. And then the whole thing equals 0. GCF in front will stay in front. And now I want to see, can I factor this? Well, first you have to count the number of terms. We have 3 terms. Do I see a value in front of x squared? The answer is I don't see a value other than 1. So no value other than 1 tells you can make 2 sets of parentheses. When I make 2 sets of parentheses here, remember for x squared, I know it's going to be x times x. I want numbers that multiply to negative 6, and they have to add to a negative 5. So be careful here. The numbers that do this are negative 6 and a positive 1, right? Negative 6 times 1 gives me negative 6. Negative 6 plus 1 gives me negative 5. Sometimes people get thrown off. They might try to use 2 and 3 because they see that 5. But to use a 2 and a 3, you couldn't get to a negative 6 and also add to a negative 5. Remember, these numbers are unique, so this is the only way to do it. Once you've done this, right, these are factored completely, and you want to set each factor that contains a variable equal to 0. Negative 1, though, does that equal 0? No, right? Negative 1 doesn't equal 0, so we're not using that. Oh. But here we have x minus 6 and x plus 1 as individual factors being multiplied to 0, so we can set them each equal to 0. For x minus 6 to equal 0, we add 6 to each side to get x equals 6. Here, subtract 1 from each side to isolate x, you get x equals negative 1. So my solution is negative 1, 6 in my set notation. The order doesn't matter if you put 6 and negative 1 in a set. It doesn't matter the order you put the solutions. The other thing I would make a point of saying is just because this came out to negative 1, that's coincidental that this was also a negative 1 we factored out. They had nothing to do with each other. This negative 1 is the solution. This was not used in the problem because when you factor out a constant, the constant can never equal 0. And let's take a look at maybe one more, just a little more challenging, just to make sure that we got it down. So if I said to solve negative 6x squared minus 32x plus 70 equals 0. So first thing is you want to make sure that you have standard form, which we do, right? So we have one side equal to 0. After that, you want to look to see, is there a greatest common factor that I can factor out from this left side? And there is a GCF in this case. It might not be obvious, but negative 6, negative 32, and 70, the greatest common factor between them is going to be a negative 2. It's negative because the first term is negative. And 6, 32, and 70 all have a 2 in common. So the GCF here is equal to negative 2. So I'm going to factor that out. When I factor it out, remember you're dividing it out from each term. So negative 6x squared factor out negative 2 makes this positive 3x squared. Negative 32x, taking out a negative 2 makes this a positive 16x. And a positive 70 factor out negative 2 makes this a negative 35. That's all in parentheses, equal to 0. When you do this, now you want to take a look at the inside, remember, and you're going to count your terms. So on the inside of this, how many terms do I see? Well, I have 3 terms. All right, and do I see a value for my x squared other than 1? In this case, you do. So that tells you want to either do a trial and error or an AC method. So we'll do this by AC method just so you know it's one most people prefer. So -2 in front stays -2. The parentheses around this whole thing are still the parentheses around this whole thing. And this whole thing is still going to equal 0. But doing an AC method on the inside of this, make sure you know you're doing it to the inside of this, not the original problem. You want things that multiply to AC. AC, remember this is A, B, and C in terms of the coefficients. So AC is 3 times -35. So we want things that multiply to a -105. You have to also add to 16, right? Whatever B is, the middle coefficient. So you have to add to 16. Now this might not be obvious to you. You might have to try a couple different factors of 105 to figure out which ones multiply to 105 and add to 16. You should be strategic about it. You know that the signs are going to be opposite because it's a -105, so that's important. So you're really looking for the difference between the factors. So like if I know 35 and 3, I know those won't add to 16, but I also can see they're 32 apart. So I know the factors have to be within that range between 3 and 35 because they have to be closer together. So, in our case here, you might not know the factors of 105. You should know that if it ends in a 5, 5 is a factor of that number, so you might want to try that out. And in this case, the numbers that we find will be 21 times -5 gives me -105. 21 plus -5 does equal a positive 16. So the numbers I'm going to use are 21 and -5. Remember what I'm doing with them. I'm replacing the middle. AC method is a rewrite method. It's a way of rewriting the middle term so you're able to use factor by grouping. So that means the ends are going to stay the same. So the -2 on the outside stayed -2. These parentheses are the same parentheses I have here. 3x squared stays 3x squared. The 16x is going to get replaced with these values we just found. Make sure you keep the signs on them. And then you just put an x with them because that's the variable piece. That's what makes them like terms. So this will be plus 21x minus 5x, using those terms there. And then we have minus 35, which stays. All right, so don't change that. Once you're here, we're going to keep factoring. So -2 in front, remember that's a GCF in front, stays in front, should be there towards the end of the factoring. Inside of here, how many terms do you see? Well, in these parentheses, I have 4 terms. 4 terms tells you can do grouping. So now inside these parentheses, this is me separating the -2 from it, I'm going to do grouping on this. So for the first group of 2, GCF we have for 3 and 21 is 3. X squared and x is just x, so 3x. For the second group of 2, the first term is negative, so we definitely need a negative. 5x and 35, they share a 5 in common. You can't take any x's because there are none with the last term. So factoring it out here, take 3x to the front. 3x squared factoring out 3x just gives me x. 21x factoring out 3x gives me plus 7. Here, make sure you have the sign with it. It's a -5, remember, because the first one's negative. Factoring it out, -5x divided by -5, watch your signs, that makes it a positive x. -35 divided by -5 makes it a positive 7. Close that parenthesis. And don't forget on the outside of all this all still equals 0. All right, last step in the factoring process is you want to make sure that you factor out what's common to both of these now on the inside. So you've got -2 in front, it stays in front. Here, what do these two terms have in common? Well, they have x plus 7 in common, times whatever's left over from the front of each of them when you factor it out. Well, that'd be 3x minus 5. This whole thing equals 0. I don't need the big parentheses anymore because it's all a product now. So now it's factored completely. Remember, if these weren't both the same as x plus 7 for these factors, you couldn't factor it out. You either made an error somewhere or this would not be factorable any further. Once you're here, you factored everything completely. You've done that, neither of these factors any further. Now what you want to do is set each factor containing a variable equal to 0. So for -2, do I set that equal to 0? The answer is no, there's no variable with it, so -2 doesn't equal 0. You don't need to use it in this problem. X plus 7, that does have a factor, so you want to say equal to 0. 3x minus 5, that also has a variable, that's equal to 0. And you want to solve these individually, so I'll subtract 7 from each side on this first one. I get x equals -7. Here 3x minus 5 equals 0. Remember how you solve this. Isolate the x terms. We're going to add 5 to each side first. I get 3x equals 5. Don't stop there. Remember, the goal is to get x alone, so divide by 3, so we get x equals 5/3. Make sure you leave that as a fraction. I don't want to see any decimals here, especially because a decimal number for something that's divisible by 3 will never be 100% accurate. We can leave it as an improper fraction is okay. So my solution set, right? So my solution, two answers here, -7 and 5/3. And then you've got it. So I wanted to show you several different examples so you get a good idea how this works. Remember, when you're doing this, the reason we're doing this equal to 0 is because we're solving equations. So it means that you started out with something that had an equal sign in there. So if you didn't have an equation, if you had an expression, you would just factor as normal and then leave it. You don't set anything equal to 0. There's a difference. You factor expressions, you solve equations. So in this section, we only had equations. So at the end, we were solving for the x values that made the equation true. If they were like our previous videos that we've seen where we were just factoring expressions, then you want to leave it in factored form. You don't set it equal to 0. It's not an equation. You don't set it equal to anything. So hopefully that helps, and I hope that this video gave you a lot of examples that would be helpful.